All right, so this summer, myself and my mentors, Alex and Laura, we studied aviation climatology in Alaska, and specifically ceiling and visibility. So we analyzed the METAR data from 146 Alaskan airports from January 1st, 2013 to December 31st, 2023. And we computed the time spent in non-VFR categories, and I'll explain what ceiling and visibility are and what VFR categories are in the next slide. So we reviewed examples of airports that experience persistent non-VFR flight conditions that are associated with more hazardous conditions. So there's two mainly important parts of like aviation climatology. So ceiling is the lowest cloud layer, and then visibility is things like fog and haze. These are the four different flight categories. The first two, VFR and MVFR. With those flight categories, pilots are able to see where they're going and they don't need to rely on their instruments. Whereas with the IFR and LIFR flight categories, pilots do need to rely on their instruments. And this is really important to consider because not every pilot, especially in Alaska with such an expansive terrain, which we'll go back, like some of these really remote places where airports are that serve communities, the pilots are not qualified to fly during these IFR and LIFR conditions. So we also looked at the different seasons, like how these conditions are throughout seasons. So on the left, we have visibility, and on the right is ceiling. And on the scale, brighter colors are worse. Those are all the times that you would have MVFR, IFR, or LIFR flight conditions. And you can see that it does tend to be worse along the coastlines, but compared to other seasons, the mountain areas do tend to be worse in the winter. And an interesting correlation here that we noticed was the winds. So you can see on the lower left there that the winds tend to be turbulent inland in Alaska, even though winds are blowing off the coast of Alaska. The first one is the 10-meter wind level, and the second one, 850 HPA, that's around 5,000 feet in altitude. Also in the wintertime, we have surface pressure. The purple area that you see here, that's known as the Aleutian Low. So that's an area of low pressure that contributes also to a lot of the turbulent weather inland. This is what it looks like in the springtime. So you can see still along the coastline, it tends to be worse conditions. And in the summertime, this is when we actually find a lot of the very worst conditions along Alaska's coastline. And you can see compared to winter how the winds have changed. And those winds are blowing over the ocean, over the Bering Sea, and picking up moisture that's evaporated. And that creates clouds that lead to those low ceilings and hazardous conditions. And this is what it looks like in the autumn. Now, one thing that was surprising is that we expected sea ice concentration to play a role in how much water would evaporate and create clouds. But surprisingly, there wasn't a lot of correlation, even though there's obviously a lot more ice in the winter than in the summer. It didn't appear to play a huge role. Especially the northern, as we saw, the northern coast of Alaska tend to have a lot of low ceilings. So here's an example of coastal visibility. This airport here in the northeasternmost part of Alaska, it had the worst visibility conditions of all the airports. So you can see there that at least 10% of the time throughout the seasons, the visibility is pretty poor. And there's not a lot of difference throughout the year as well. So here's some examples of how mountains are inland in Alaska. So Perry is south of Alaska's northern mountains, and it has You can see that the visibility is worse in the colder seasons than in the summer. And then similarly, so that one is ceiling, and then on the right we have, or on the left is visibility and on the right is ceiling. So again, the ceiling is also worse at this airport in the southern mountains in the winter time than in the summer. And in contrast, these are the coastal areas and the islands. So Patsy, which is an airport in Ruby, Alaska on the western coast, over 50% of the time in the summer, they have what's are the worst conditions, LAFR. So those would be the lowest ceilings, like very low cloud layers. And also PASN, that is an island in Alaska just to the west of the coast. So we noticed that Alaska's coasts and islands tend to have the worst flight conditions. Mountains in Alaska see more adverse aviation weather in the winter. And further study could greatly benefit aviation weather products throughout the state, and especially for those really remote communities that rely on aviation throughout the year, since there's often no roadways. And so hopefully more detailed studies can be conducted in the future. Here are my references. And I would like to express my deep gratitude for everyone who has supported me this summer at RECCS, Amy, Alicia, and Carla, and all of my cohort. It's been amazing working with you all. And at NOAA, Alex, and Laura, and Lindsay, and Matt. I really enjoyed being at NOAA this summer, and I learned so much about weather. And also to my family and friends, my mom's siblings, and my friends. Thank you all so much. I love you, and I'm happy to take any questions.
So during those like really low visibility times, do the pilots still have to fly, or is it like a certification thing where they're just like not even allowed to?
So that does depend on the pilot certification. So like at larger airports, and especially with commercial pilots, they are trained to solely rely on their instruments, so they could fly. But then in more remote areas, like with general aviation, if they're not qualified, then they can't fly, like it's not safe to. So having more accurate weather models in the future with more accurate predictions could, it could really help us make more accurate understanding, so that like then pilots will know, is it going to be safe to fly today, or do I need to like wait later?
Do you think as like temperature changes just kind of all around, will our visibility get worse and continue to change accordingly, I guess? Do you think?
Are you thinking like with climate change?
Yeah.
It's possible because like a lot of those clouds, especially on the coast, like they're driven by warm air blowing over the ocean, so that is possible.
Also take into account the 6 months of no sun as well for the visibility.
So I looked at the temperature charts and I didn't notice any correlation. There could have been that I just didn't notice. But that is one really interesting thing about Alaska. Its position between two global circulation cells. And again, yeah, like its position in the Arctic Circle really does create, and the mountains and coasts, it really creates an environment that's very dynamic atmospherically.
Okay, great. Thank you so much.